Here, we're going to practice classifying chemical reactions. We're going to look at a whole bunch of them, and we're going to figure out what type they are. So here are the 5 major types of chemical reactions. For each, I've written a sort of generic example equation that shows what the reaction looks like. Now, just a heads up, the equations that we'll be using in this lesson are unbalanced, because for right now, I just want you to focus on the elements and how they're rearranging, and I don't want you to worry about getting distracted by the coefficients. Okay, so let's start classifying reactions. Here's our first. Magnesium and aluminum chloride give us aluminum and magnesium chloride. So what's happening here? We have aluminum and chloride paired up here. Magnesium is on its own. And then magnesium comes and takes the place of aluminum. Magnesium pairs up with chloride and kicks aluminum out. So when something like this happens, we're talking about a single replacement, also known as a single displacement reaction. C8H18, which is the chemical formula for octane, and oxygen gives us water, H2O, and CO2. So whenever we have something with carbon and hydrogen and we add oxygen to it, and we get water and carbon dioxide, that is a combustion reaction. So this shows us the combustion of octane, which is one of the components of gasoline. Magnesium chloride turns to magnesium and chlorine gas. What's happening here is a compound is breaking down into simpler components. This is a great example of a decomposition reaction. Magnesium and oxygen combine to give magnesium oxide. So what we have here is we have 2 simple things coming together to make something more complex, which is what happens in a synthesis reaction. So this is a synthesis of magnesium oxide. Now just real quick, I'm referring to this chart to help classify the reactions, but chances are you wouldn't be allowed to use one like this on a quiz or a test. Okay, so just make sure that you really learn these sample equations for each reaction so that you're totally good with this when you run into it on an exam or something. Silver nitrate plus sodium chloride give us silver chloride and sodium nitrate. What's going on here? Well, we have 2 pairs that then switch their partners. Silver was initially paired up with nitrate, and then silver ends up pairing up with chloride over here. And sodium was initially paired up with chloride, and then sodium ends and switches up here with nitrate. So this, where we have 2 pairs switching partners, is a really good example of a double replacement reaction. Sodium carbonate turns into sodium oxide and carbon dioxide. So here we have a compound breaking down into simpler compounds. This is what happens in a decomposition reaction. Now, in this decomposition reaction, we don't see this compound breaking all the way down to the elements that make it up. We're not getting just sodium, carbon, and oxygen, but it's breaking down into simpler compounds that themselves are still combinations of more than one element. But that's okay. It's still a decomposition reaction, just as long as we have something complex breaking into simpler pieces. Zinc by itself and HCl, which is called hydrochloric acid, give us zinc chloride and hydrogen gas. So what's happening here? Well, look at what's paired up together. Hydrogen and chloride here are paired up, and then zinc by itself pushes that hydrogen out of the way and ends up pairing up with chloride, giving us hydrogen by itself. So when this happens, when an element on its own kicks out another element and takes its place in a pair, that is a great example of a single replacement reaction. Sodium chloride and H2SO4, known as sulfuric acid, come together to give us sodium sulfate and HCl, hydrochloric acid. So what's happening here is we have 2 pairs of 2 different things. We got Na and Cl and H and SO4. They switch places. So the Na that used to be paired up with the Cl ends up pairing up with the SO4, and the H that was initially paired up with the SO4 ends up paired up with the Cl. So this is an example here of a double replacement reaction. Okay, here's the last one. C6H12O6, which is the chemical formula for glucose. It's a sugar and food that you eat. Glucose combines with oxygen to give us carbon dioxide and water. All right, this should look pretty familiar. When we have something with carbon, hydrogen, and sometimes oxygen, and we combine it with oxygen, we get CO2 and H2O. That is an example of a combustion reaction. This is a great combustion reaction to look at too, because this is one of the examples where what we're burning, what we're combusting, doesn't just have carbon and hydrogen in it, but it also has oxygen. Remember that it's also possible to burn or combust things that have carbon, hydrogen, and oxygen in them as well. The rest of the combustion reaction looks pretty much exactly like it does when you have something with only carbon and hydrogen. So those are a whole bunch of practice problems for classifying these chemical reactions. If you can work through these, if you learn these different example equations, you should probably be totally fine.